that it might be useful. But what I am showing here is the list of papers on drought. Okay. So, they are all varieties of topics. Like I said before, you have to see the relevance on some of them are old, some of them are new, but do not worry about the location, do not worry about the location, but just look at the process that we followed. The equation that I am talking about here is soil moisture index that we used for deriving soil moisture based drought index based on observed rainfall. I call SMI or SMDI, I think, depending on the paper, but it is all more or less the concept is the same, using field capacity and wilting point from the data and then coming up with soil moisture index. This one was one of the first ones of its kind at that time, looking at user friendliness in severity, area, duration assessment of agricultural drought. So, if you have good data for soil moisture up to root zone depth, which is about 150 centimeters, 120 to 150, that is ideal for crops that grow up to that deep. Sometimes it may be even shallower than that, but so it depends on the crop type. If they are rain fed agriculture, not irrigated, can you imagine what would be the root distribution compared to the irrigated agriculture? Any idea? What is the difference between rain fed agriculture and irrigated agriculture? Yeah, only dependent on the rainfall is rain fed agriculture, obviously. What about the other one, irrigated agriculture? So, rain fed agricultural crops, maybe I am not coming up with a question correctly here. So, I will take the blame, which is if you put the plant in a rain fed agricultural crop, they are going to be searching for moisture, right, all the time. They have to go wherever they can fetch water. So, some crops are really deep, they can go deeper up to even 1.5 meters like corn and sorghum, but paddy or anything that you really feed them with water all the time with ponding depth, they do not go too deep, because they are getting water at their doorstep, which is the roots, basically they do not fetch water going deeper. So, there are differences in the way how soil moisture is measured depending on the type of crops. So, you want to make sure that you have the right data for your region to interpret them. But this paper is very interesting because we were able to showcase how soil moisture is used in combination with models, not so complicated to understand, but you may be able to use this for predicting drought. Just try that first as a first paper to read, but then there are other papers that I talk about, like the flash droughts, using pentads, and then using models and combination for coming up with drought index like MSDI in this case, modified or multivariate soil moisture based drought index here in this case. So, two different models, and we also compared that with GRACE data, that is total water storage, which will represent the deeper soil moisture to some extent. So, we kind of combined that, but you might be interested the latest article on this paper, which is Satish Kumar's paper on reconstructed data. Especially if you want to break new grounds with respect to combining machine learning to GRACE data, that is remote sensed, and then coming up with using current data, but then going back historically. So, we built this, so we call this as a reconstructed data up to 1960. If you look at the time series that we came up, this is for the whole South India again. We included Godavari, Kaveri, Pennar and Krishna, all 4 of them are here. So, these are observation well sites. So, we tried to validate some of these total water storage from GRACE with observed data also, but this is a well written paper by, all the credit goes to the first author, Satish Kumar. He explained all the details of the model. You might be really seeing some interesting data from this also that you can use. Again, if you are citing this paper, using this data, you can cite this paper also, but the idea behind what I am trying to show here is the corresponding, I am sorry, here I am going back to the historic data, 1960 all the way up to 2016. So, we are talking about by basin that we are building the data like Godavari, Krishna. You can just take one basin, you do not have to go for the entire South India basins. Those who are studying Tamil Nadu region take only Kaveri, those who are Palar, Pennar, and then these 2 other basins, those who are studying Telangana, Andhra Pradesh region can take the reconstructed data. You do not have to redo this again, okay. But give the credit to the author who developed this data, but it might be useful by citing their work. But all I am trying to say is they are very good in terms of correlation. We are able to prove that the predicted TWSA for the historic times when you do not have data to validate is still reasonable, because if you look at the segments here, the right side is the recent times from 2002 onwards, that agrees very well with our machine learning based predictions. So, then we extended this to backward, all the way up to 1960. So, then we have to give, have some trust on this data, because it is proven to be correct for the recent times. So, that is the justification. So, somehow you have to build your foundation on validation aspect of it. That is what the papers actually look at. So, this might be a very good paper. So, what I have done, and then this paper is one of the highly cited paper that I was talking about on Coppola based approach that I am saying. This again some of you asked yesterday also, the parameters what to use, that peak, we kind of define all of those things here, peak, severity and duration, and then of course, this is based on that run theory that we talked about, and then this has got all, I think there may be link for the code also for this. You can kind of extend this multivariate analysis. It is little complex in terms of first time reading and understanding, but what I am trying to say is Coppola based approach has been widely liked by the people because it covers the uncertainty aspect of it. So, read them through. There are also, whenever you see some information that is missing, you can refer to the supplementary part. We put either the code or the data or where we got the data from, all kinds of additional information. So, before you reaching out to me, if you are referring to this paper, try to understand whether or not there are supplementary materials available for the paper that we published. Most of the time we do attach our data associated with that directly into the supplementary material. Okay. So, likewise you have tons of opportunities here to explore further. I will not expect you to read all of this before tomorrow 9 o'clock, believe me. Okay. These are given to you to take home, whatever you want to do with this, but it is for your long term library of articles. I mean, as PhD scholars and graduate students, masters and PhD and undergrad researchers who are doing active work can keep them for archival purposes, refer them, because sometimes it might be helpful for you. Okay. With that, I am going to stop here, but I will come back to the video part later, because some global context I want to still give. But any questions on these papers, or I will post them on day 6, because I started drought discussions on day 4. That was my dilemma that I had before, whether or not to post this file on day 4 or day 6. So, you will see drought files are updated from day 4 to day 6. So, you refer only to day 6 files. So, I will also post all these articles under day 6. Okay. So, with that I am going to actually take the last 10 minutes to talk about or 15 minutes to talk about this machine learning based forecasting of stream flow, peak flows. Again, this is a very interesting work done by Amina Khatun from IIT Kharagpur. Okay. Some of you might know the names that are well established in the field. Effective approaches using physical models and AI/ML techniques to predict hydrologic extremes. Mahanadi, as we all know, it's I am sorry if you guys are wanting to take a picture of this, but I think I posted this paper already on day 3 folder. You can check that out. Okay. Mahanadi in India is one of the flood prone basins, as you all know. Hirakud Dam is there. Of course, the rainfall average is about 1400 millimeters on an average, especially during monsoon. 4 to 12 degrees Celsius of minimum and 42 to 45 in December, December through June, high numbers. And the storage capacity, live storage capacity of 4,823 times 10 to the power 6, that is 4 million acre feet of live storage, and spillway capacity of 1.5 cubic feet, million cubic feet of Hirakud reservoir. So, it has a cushion, but does it mean that it can still be sufficient for future extremes? That is a question that we do not know. We want to understand what is the fluctuation in the peak flows that you will have for this region given the extreme events, particularly with sea surface temperature confusing the cyclonic storms emanating or originating from Bay of Bengal region. So, it can really create some uncertainties. So, data is very important. In the past, of course, if you see the extreme events even in the last 10 years, 20 years, 2001, 3, 6, 8, 11, 14, 17, 20, 22. So, almost every other year you are seeing floods, right. So, it's a problematic situation right now. This is again basics, you all probably know this. So, I am just repeating this. Convolutional neural network has attracted global attention because it is able to replicate the data features if you just use CNN. But then if you use LSTM, long short term memory method, exhibits the ability to store the information in their memory cells for a longer period. So, if you want to really combine the data features that are captured by CNN with another machine learning algorithm of LSTM that captures for a longer time, that is a good combination. And then of course, structurally improved version of LSTM named gated recurrent unit GRU with less number of operation gates, simpler in structure as compared to LSTM, that is what people are using. However, all these models, standalone models, are not really sufficient right now. That is what people are coming up with. Just one model alone is not sufficient. Can we really come up with a hybrid model? That is the next level of thinking. So, hybridization of these models by integrating them has been a kind of a new interest right now. So, this study actually developed 4 standalone models, ANN, CNN, LSTM and GRU, and then 2 hybrid models, CNN, LSTM, CNN, GRU for daily stream flow forecasting. But again, the number of variables that we are using is dependent. Of course, I put these figures just to give you the context. We will not get into the details of it, but the paper will tell you more about it. But some of these are literature kind of paper, right. So, you can fully dive into this deeper if you are interested further. But machine learning algorithms, machine learning models, before you use, one thing that you have to be careful about. What is that? What is the one thing that you have to be careful about machine learning models? Very good, quantity and quality, because if you do not have enough data, it is reading from the data, right. Basically, it is going to capture the features like CNN that we are talking about, capture the memory from LSTM. If both of them are kind of truncated because of lack of data, there is no point in doing machine learning models. it will not be perfect, right. That is the basic understanding that you should have. If you do not have enough length of record of data, it is not worth your effort. These are data hungry models or approaches. So, the selection of suitable input variables along with appropriate length of past information is crucial. So, number of variables to predict, like drought what we talked about, like floods, we need to rely on a combination. Nowadays they call physics guided model also driving these variables, right. So, in our case what we did was we tried to come up with a combination. I do not know whether I have that slide here, but going quickly through this right side of this, one is CNN, the other one is ANN, the first one is ANN, CNN, and then we have LSTM and GRU. Basically you have the same structure, input, hidden layer, output layer, and then of course you have some combination of the gate or GRUs here, hidden layers. The hybrid models that we came up with was two of them, CNN, LSTM, CNN, GRU models. So, you can imagine of course, by designing a setup like this and coming up with a flow chart for process, variable selection is first important one, and then we talk about data preparation, which is going to be a time consuming process. If we are not building any physics based models in this case, but we are talking about cleaner data, quality data, that is very important. So, we spend a lot of time I think in terms of preparing and pre-processing the data, and again splitting the time series data. I think we used 80-20 kind of split, training and validation or testing, defining the network, like how many number of hidden layers, cells and activation functions and time steps, and then defining the hyperparameters, number of epochs, batch size and dropouts. These are machine learning algorithm syntax. You can easily get the basics by reading the available literature on those. Then defining the loss function, that is the main thing there, training the network for sufficient period, and then validating and evaluating the model performance. This is pretty common, right. This is what we do for any algorithm development, machine learning based. One thing I wanted to say is of course the input parameters. I do not think I included that slide here. So, the parameters that we used, a combination like precipitation only, precipitation temperature, stream flow, like that. We had in that paper we talk about 15 different variable combinations that we used. So, 15 different variables of you can see we also use two different methods of correlation based and constant lagged input methods for deriving these parameters, input variables, and then 6 different models for forecasting lead time of 3 days, forward forecasting up to 3 days, day 1, day 2 and day 3. So, it quickly builds up. The reason I am trying to say, what I am trying to say here is that 6 models, 15 variables, 2 different types of combination of inputs, constant based, correlation based and constant lagged, runs the simulation options or combinations became in thousands quickly, thousands. So, unless you have powerful computer, you cannot do this work. You want to make sure that you have access to maybe high performance computing, GPUs or whatnot. So, that is another constraint. I mean, you cannot use your laptop and say I am going to do machine learning algorithm by doing all these things. You may be able to do it, but it will take probably a long time to do the work. So, before you dive deep into this kind of analysis, make sure that you set the problem correct and see the resources whether or not available, whether or not you have enough data to do this kind of work. Just because it is a buzzword of using machine learning to develop some models and publish means it is not that that easy. So, I would say because you will be when you are submitting even the paper, there may be some issues with respect to quality of the analysis with the data that you have limited, or even you may not be able to get there because if your computational resources are limited. So, we had that limitation. We tried to extend this work in another settings, but we could not do it with laptops or powerful computer at our desk. So, we had to rely on advanced research computing at my university to run these simulations. So, not for this one, but for the other project, similar project. So, now coming back to, so I am just giving you the broader framework before you dive deep into the analysis. So, coming to this one here, what you are seeing is ANN, CNN, LSTM for 1 day, 2 day, 3 day forecast. I mean up to all the 6 models that I am showing here, combination of CNN, LSTM, CNN, GRU. Then we looked at the model performance here, measured versus observed or simulated versus observed data for 1 day, 2 day and 3 day. Obviously, of course, you can see based on these equal value plots, the scattered plot that you see, the data points are tightly connected or tightly hugging the one-to-one line, showing that the agreement between observed and modeled are tight with respect to day 1. Day 2, it is getting better, it is still not great as day 1, but day 3 is not good at all. So, it falls behind, or it does not do a great job of predicting peak flow for day 3 even with all these combinations, but CNN LSTM is little bit better for, I mean I am not showing all the metrics, that paper has all the numbers, you can refer to that, but all I am saying here is that by cursorily looking at this graph, what you can say is CNN LSTM and CNN GRU hybrid models are doing better for predicting peak flows based on these 2 statistics that what we came up with. So, again looking at the peak flow for 1 day, 2 day and 3 day, what you are seeing, this is for testing period, that is for training and testing, this one is testing. What we are seeing is 1 day very tightly matching all the 6 models, maybe one is probably little bit off for the first day discharge wise, but then for 2008, but 9, 10 and 11 you see pretty good correlation for day 1 simulation of all 6 models of peak flow. So, that is a reasonable thing to expect, within 1 day you can predict. You remember I was telling, if you know your things as of today correctly for temperature, you can predict, let us example this temperature, you can predict definitely with much more confidence for tomorrow, but the day after tomorrow you may not know, or 3 days forecast you may not be 100% accurate. So, that is what exactly we are saying, day 1 is always better, day 2 all 6 models are kind of still okay, but day 3 you can clearly see they are kind of, some are doing better, some are not doing better when it comes to peak flows for the same period 2008 to 2011. The takeaway of course from this is CNN LSTM and CNN GRU is better for up to 2 day lead time, but the selection of input variables will be really critical. Out of 15 different combinations, I do not exactly remember which combination we used, the one that I am showing here, but it is 4 combinations: precipitation temperature, daily discharge at the outflow or the upstream, and one more variable that I cannot remember now. So, all those kind of combination of variables played a better role than having only precipitation temperature. Consideration of discharge points upstream of the watershed is very important, because that is where the runoff generation starts, and your target point would be outlet, right, basically your downstream location, but you can, if you have multiple points you can use multiple, or you build the model for a few locations or one location, transfer to other places. There is another option for doing the transfer function also. Developing CNN LSTM in this case does a good job for Mahanadi. It may be the same for any basin that you look at, Krishna Godavari for this case, but some effort to to really see whether or not machine learning works for it. It could be just inflow prediction using machine learning algorithms. It does not have to be peak flow. I mean, peak flow is an example, but it could be inflow. That means you can even have a combination of physics guided models included in them. So, variety of ideas approaches that you can have for building machine learning based approach. This paper I have posted. I think that link also may have information on the code that is available, but if you are using this paper, cite it, and maybe if you need any additional information, either you can write to me or to the first author. There may be some options available for you to help. Okay. Questions on this? Yeah, I think so. I would like that. Hydrological models, you do not need HPC unless you go for WIC model for a large area, because it is a gridded model. It needs all kinds of, and depending on the number of years of simulation that you want to do, but you can do still better with if it is a WIC model, it is a Linux model, it is not a Windows based model. So, you have to run it in Linux version, reasonably okay. You can, you do not need HPC for that, but if you are using machine learning for the same scale, definitely you need a powerful computer. A cluster would be good. Okay, if okay. Yeah, upward or uploading and downloading only thing if yeah, because you may be able to run it and store it there, but if you R squared, I think is the one we used, 0.7 and above, yeah, is better, but I think ours was reaching even up to 0.85, 0.9 some cases. You are asking the basic algorithm of how they are different, right? Do not ask me that question, because I think I did not do that. Yeah. Well, store that question. I think this will be covered on Monday when they are talking about different machine learning algorithms. I think Dr. Venkat Reddy will start with that. Maybe if that is not covered, then we can talk at that time, but I think this paper also may have that information, but I that graphic that I showed will have even the differences slightly explained, but I do not know if they are basic stuff, it may not have been included, but roughly speaking, I think for each of those graphics there was some explanation attached. So, please look at that and see if you can discuss with me after that, after you read those. Yeah. 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 Oh, why is it needed? Oh, why means obviously you do not trust your model. Once you build it, you have to validate, test and validate. So, certainly keep some data that is not used, otherwise it will not be a perfect model that is available to you. That percentage split is depending on the length of records. I would prefer to have longer period even for testing also, but we were constrained with the limitation. So, we wanted to come up with a better model. So, used most of it for training the model. So, you can I mean you have to explain in any analysis, do not go beyond the literature suggested anywhere from 70 to 80, but if you go beyond that they may have some questions in the review process when you submit, but 70 to 80% if you use for training and then remaining for testing and validation, that is fine, you can do that. Oh, that is true. Another thing I forgot to mention, good point. Model can overfit because it is getting confused with so much of information that you give, right. It will capture all kinds of information that is available to it, and then finally it will be like your masala mixed up and nothing you will taste, distinctly, khichdi, right. Yeah. Yeah. That I do not remember, but there is a 15 combinations. There is a table 2 or 3 that you can refer. I think we tried all combinations, PT, stream flow up with upstream gauge station, and maybe other combinations, but important ones. Yeah, I would say if it is peak flow, certainly P, T and anything to do ET also I think would be of use, but it depends on the question that you are asking for a machine learning model to use. What is your ultimate variable that you are predicting? So, that will drive what are the important ones. Yeah, runoff, I would say all water budget terminologies that we are using, if you have access to those data, use most of them. Yeah, but fitting with the data will help you first. I mean, trying to fit the data with the different combinations will tell you which one is, I mean, that is the beauty of machine learning. It is like your robot, right. I mean, it does not think, I mean, it thinks, but what I am saying is it does not think like humans. It takes all things into consideration and gives you the best fit, and then you can interpolate or interpret what it tells, whether or not it misses some of the variables or not. You feel comfortable by adding more, then you do that manually. But I would say trying with different combinations even mechanically without even thinking is possible with this kind of approach. I want to save the last 5 minutes at least for showing the last part of one of the videos, but maybe that is just to give you an idea. It is again another continent. We talked about North America for drought, we talked about Australia down under. So, 2 extremes, 2 corners, but then in the middle African continent. For India, of course, you are all familiar, you are much more familiar by witnessing yourself first hand of drought. Wherever you are coming from, you cannot say that I have not seen drought. You must have seen at least once or twice in your lifetime, right, whichever region you are coming from, north or south, west or east. So, with that, oh, by the way, I wanted to show something here. I did quickly, but time is running out. Let us say if I can finish with this one and Uttarakhand, Chamoli, I want to show some photos. We used this small drone. We flew this over Malawi. Yesterday, you remember in our presentation they talked about structural level information they are giving when the storm surge or sea level rise entering into the neighborhoods and inundating, and the scientist that was describing, they can go first story building, 2-story building or 3-story building, and they will evacuate the ones that are in the low levels. We did that kind of work couple of years ago for Malawi, tin versus thatched roof, and this is a combination of SWOT model, drone data, and then we kind of mapped which ones are vulnerable for floods. It is an interesting paper to refer to. So, we are able to kind of use the drone technology, hydrology model to come up with making some decisions about how to help people for deciding on the disasters, helping them during the disasters. The next disaster that I am going to talk about is the Chamoli land or glacier collapse that happened 3 years ago during COVID, that is why we all wear masks. You could see we got this drone from, we have Virginia Tech has a branch in Chennai, Virginia Tech Chennai Center. So, we took that all the way to the Himalayas. This is Joshimath in Uttarakhand, few kilometers away from Rishikesh. I may be mixing up the geography, those who are from that region excuse me, but I think it is basically east of Roorkee, Haridwar, Rishikesh, and then going all the way to Joshimath to Chamoli, the mountains. So, we took this heavy stuff, it is a nice collaboration effort by all the scientists, drone pilots, 17 of us went. We went to the Ganges in the upstream areas. This is a scientist, Dr. P.K. Mishra, helping to collect the data on velocity. We were collecting the velocity of the river. This is the dam that I was talking about, the thermal or Tapovan gates. One of the gates broke open or breached, and it destroyed the area, and 73 plus people died. The pillar you can see there, it is really a huge one, that is totally blown away, amazing. And I tried to even measure the diameter. Can somebody tell me what is the diameter of this? Three meters, it was somewhere close to that. Yeah. So, and then they built some temporary bridges right now, and then these are that scientists. This is Dr. Deepak Bisht from NIH, very active scientist, but we all collected soil samples and then took flow data. We are trying to fly the drone, collect some data. The work is still not completed, but for disaster modeling you need really ground truth, ground data for validation, or even to understand what has happened exactly. So, sitting in front of computer is one thing, but actually going to the field and collecting information is very helpful, whether it is floods or droughts. We will stop here and then continue afternoon, but I will show you a quick video. Maybe if we can tell them to stop, I think that will be great. Thank you. We are not done yet. 3 meters, it was somewhere close to that. Yeah. So, and then they built some temporary bridges right now, and then these are that scientists. This is Dr. Deepak Bisht from NIH, very active scientist, but we all collected soil samples and then took flow data. We are trying to fly the drone, collect some data. The work is still not completed, but for disaster modeling you need really ground truth, ground data for validation, or even to understand what has happened exactly. So, sitting in front of computer is one thing, but actually going to the field and collecting information is very helpful, whether it is floods or droughts. We will stop here and then continue afternoon, but I will show you a quick video. Maybe if we can tell them to stop, I think that will be great. Thank you. We are not done yet.